So today in section 5.3, we're going to add and subtract and multiply polynomials. This is mostly review stuff from Algebra 1. Not much new Algebra 2 stuff in today's lesson. So maybe it will be a good, easy lesson for us today if you can remember how to do things. Let's start with adding and subtracting polynomials. This one right here is a third degree polynomial because its largest exponent is the third power. Same with this one. And we're going to add these two polynomials, and they're separated because they have parentheses around them. And we know it's addition because there's a plus sign between the two parentheses. So I know there's a lot of pluses and minuses going on. But you look between the parentheses, and that tells us that's a plus sign, so we're adding the two. So if you're adding two polynomials, all you do is combine like terms. Now let's talk about like terms for a minute. Okay? Like terms have to have the exact same variables with the exact same exponents on them. So an x and an x squared are not like terms, right? An x squared and an x to the third are not like terms. So just because they have an x doesn't mean they're like terms. They have to have the same exponent with the x. Not if they don't have the same variable. Same variable, same exponent. Okay? Same thing with numbers that do not have variables. Those are called constants. Constants are only like terms with other constants. Okay? So, when you do this, you need to do it in what we call decreasing order. That means you start with the highest degree and work down. And when I say degree, I'm talking about the power, the exponent. So what's my highest exponents I have in these two polynomials? X to the third power. So I have two things with x to the third, right? So I have 2x to the third plus 1x to the third. So you add the coefficients. What's 2 plus 1? 3. And you keep the exponent. It's not x to the 6th. It's x to the third. So when you combine like terms, you keep the exponent. You add or subtract the coefficients, and you keep the exponent. Okay? So after x to the third, what's the next highest exponent? X squared. So we've got a negative 5x squared and a positive 6x squared. What is negative 5 plus 6? Positive 1. And you can just put plus x squared if you want to. You put plus 1x squared, or you can put plus x squared. All right, going on down the line, after x squared comes x to the first power, which is just x, right? Do I have anything that has just an x? 3x. Does it have a buddy with it, has like terms with it? No, so we just copy down plus 3x. So if it doesn't have a buddy, a like term buddy, you just copy it.
And then positive 3.
Try again.
2.
Yes.
Well, that's what I'm
Sure it is. Okay. So then I know the constants are like terms with each other. Negative 9 plus 11 is a positive 2. Again, your answer should be all different exponents, and it should go highest to lowest exponent. So that is our answer. So if it's adding, that's what you do. Just combine like terms. Okay? If it's adding, just combine like terms. So let's talk about subtracting. 8x to the third minus x squared. Now I see a lot of pluses and minuses here. So how do I know I'm subtracting these polynomials? Yeah, you look between the parentheses. Okay? You look between the parentheses. So if you subtract a polynomial, what you have to do is distribute a -1 to the second parentheses. Now, what does multiplying times -1 do to terms?
Make them all negative. And the
So
negative makes it positive.
Yeah, it changes the sign, right? So it means I'm going to copy the first polynomial just like it says. I'm going to drop the parentheses though. So do not change the first one. Copy it just like it says. And if it's a subtracting polynomials problem, the second one you're going to change all the signs. So that's going to become a -3x to the third, a -2x squared, a positive x, and a -7. So if you're subtracting two polynomials, your first step is to keep the first polynomial the same, change all the signs in the second one. And then you're going to combine like terms again. Okay? So we're going to start. What's my highest exponents we got?
8x squared cubed.
All right, so the x to the third is x cubes. So I got this one, and this one I have x to the third power. So combine their coefficients. What's 8 minus 3? 5. So that's 5x to the third.
And then the x squared.
Then
2x squared.
So, yeah, -x squared minus 2x squared is what?
-3x squared.
-3x squared. And then
you got the 5x.
5x plus 1x is what?
Is 6x.
6x.
Plus you got -6.
Yeah, +1 minus 7 is -6. And there's your final answer.
How come you can't add 5x squared and cube and 3x squared?
They're not like terms. They're not like terms.
It's just the exponent.
But can you add 5x plus 2? Oh, same thing.
Or another variable.
Yeah. Y'all need to do another subtraction or you think you're good?
We're good.
So addition,
Easy. You just keep
combine
going.
like terms, yeah. Subtraction, keep the first one, change signs on the second one. Okay? Now we're going to spend the majority of this lesson multiplying polynomials.
So it's the same concept, but in useful form.
Well, kind of. Let's start with something easy. This is example C. All right. Let's just talk about the names for polynomials for a second. If it just has one term and no pluses or minuses, it's called a monomial. So that 3x to the third out there is called a monomial. If it has two terms, it's called a polynomial, but specifically if it has two terms, it's called a binomial, right? How many wheels does a bicycle have? 2, unless you're in training, right? Okay. 2 wheels has a bicycle, and a trinomial has how many terms in?
3.
3, like a tricycle has 3 wheels. So this one is a monomial times a binomial. So when you have a monomial times a polynomial, you're just distributing. Okay? You're going to take that 3x to the third and multiply it times this term, and then multiply it times this term.
But it's not the exponents.
Well, that's fine because you're multiplying. And we learned yesterday that when we multiply exponents that have the same base, what do we do to them? Add them. So now we're multiplying. We're not adding and subtracting anymore. We're multiplying. So when we multiply and they have the same base, we add the exponents. So multiply the coefficient. So what is 3 times 2? 6. Multiply numbers, add exponents. Multiply numbers, add exponents. And then we need an x. What is, no, 3 times, 3 plus 2 is what?
5.
5. To multiply same bases, we add. Y'all with me? Okay. Now it's the first term. Now I'm going to multiply 3x to the third times negative 5x.
That's negative 15.
So 3 times negative 5 is negative 15, right?
Q, x cubed.
Gonna be cubed or gonna be 4?
Well, this is what exponent.
1.
And 3 plus 1 is 4. So it's x to the 4th. And that's your answer. Boom. Multiply the numbers, add the exponents. Because when you multiply two things with the same base, you add the exponents. We learned that yesterday. I would be better at it if you'd have done the practice. Okay. So now let's multiply a binomial times a binomial. If you heard of this in Algebra 1, you might have heard of something called FOIL method.
First out of your last.
FOIL method. First outer, inner, last.
First outer, so x5x.
So that means, let me write down FOIL. That means you multiply the two first terms together, the two outsides together, the two insides together, and the two last terms together. All right? I like to think about it more like distributive property, and you're going to repeat distributive property. You're going to take the x and multiply it times this term and this term, then you're going to multiply the 3 times this term and this term. Same thing. It's the same thing as FOIL. Okay? If FOIL helps you do it better, do FOIL. If you can distribute better, do distributive. Okay? So if I multiply the two first terms, what is x times x?
2x.
No, that's x plus x.
X squared.
X squared. So x times x is x squared. What is x times negative 5?
5x.
Negative 5x. Good. Then I do the inside terms. What's 3 times x?
3 cubed, x cubed.
I don't know where you're getting that. 3 times x. 3x. And what's 3 times negative 5? Negative 15. And the very last step to this is combine any like terms. Do we have any like terms?
X.
The x is in the middle. So that's going to be x squared. And what's negative 5x plus 3x? Negative 2x. And then copy the minus 15. And that's your answer. So I don't care if you FOIL it. I don't care if you distribute it. You still should get the same thing. Okay? Because you're still doing this times this, this times this, this times this, and this times this. Okay? Just however you can remember it. Let's do another one like that, a binomial times a binomial. Because these are kind of very common. 3x minus 5 times 6x minus 4. 3x minus 5 times 6x minus 4. So you can FOIL it, you can distribute it, whatever makes you remember what to do next.
3 times 6 is 9x.
Squared. It's 3x times 6x is 9x squared. X times x is x squared. Y'all with me there? And then you multiply what?
3 times 4.
3x times negative 4 is what?
12.
Negative 12x. And then the two inside terms.
Negative 5 times negative 6. And negative 5 times 5 is
6x.
Yeah, 30. 30x.
Negative 30x.
Negative 5 times negative 4 is probably 20.
Good. So any questions on that multiplying?
And you add them together.
Combine your like terms. What's
42, negative 42.
Yep. So it's 9x squared minus 42x plus 20. And that's your answer. After you combine like terms, you're done. Any questions on that? A binomial times a binomial. Like you said, if FOIL help you remember it, do FOIL. If you can distribute both times and get it, that's fine. And the reason I like distributive property is that's what we're going to have to do on the next kind of problem. which I need space for. Dun, dun, dun. X plus 3 times x squared minus 4x minus 5. Hang on a second. This is a binomial times a trinomial. So you have to distribute, and I call it repeat distributive property because I'm going to multiply everything in the trinomial times the x, and then I'm going to come back and do everything times the 3. Okay? So the x gets multiplied times all 3 terms, then come back and multiply the 3 times all 3 terms. And then at the end, we'll have to combine like terms. So this is going to take a little while. Okay.
2.
X times x squared is what?
X cubed.
Yep, add your x's. X to the third. What's x times negative 4x?
Negative 3.
X times 4x. Negative 4x squared. If I'm multiplying times x, I'm just giving everything one more x, aren't I? Yeah, that's all I'm doing. And what's x times negative 5?
Negative 5x.
Negative 5x. So I'm done with all the x's. So if you multiply times just a variable, you just give everything that variable. They get one more. Okay? We'll erase my arrows for a second. So now I'm going to do the same thing with 3. We'll start over with 3. So what's 3 times x squared?
3x.
What's 3 times negative 4x?
Negative 4x.
And what is 3 times negative 5? Negative 15. And I'm done multiplying. Any questions on my multiplication?
Add the x squared together.
So now we got to combine like terms. Highest to lowest. X to the third. Does it have any buddies?
Yep.
X to the third has another x to the third?
Oh,
No. So copy it. And you can cross them out. I like to underline them as I do them. What else comes after x squared? Or x to the third is x squared. So negative 4x squared
negative.
plus 3x squared. So that's negative x squared or negative 1x squared. And then the x's, negative 5x minus 12x is negative 17x. And last we have the little constant doesn't have any buddies. So you just got to write him down. And there's your answer. That's how you do a binomial times a trinomial. Now let's do one more of those. And next we get to have even more fun.
So do you add binomial with trinomial?
We do that like we did at the very beginning. If you're adding them, you combine like terms.
It don't matter if they're mono, mono.
If you're adding any kind of polynomial, if you're adding them, you just do like we did at the very beginning, combine like terms. Yeah. Well, last night's was easy too, but you wouldn't know. I just gotta give y'all a hard time. Hoping the guilt factor works a little bit. So again, I got a binomial times a trinomial again. So what do I do?
2 times 3.
Not just 2 times 3, say the whole term.
6.
No, tell me what you're doing.
2x
Times.
3x. Or 3x squared.
Thank you. Okay. 2x times 3x squared is what? 6x cubed. Good. And then I multiply 2x times
6x.
3x.
6x.
6x. What's x times x?
Cubed.
Squared.
Then that's a 2.
Okay. Then I multiply 2x times 5.
10x.
And that's 10x. Then what do I do?
3 times 3x cubed.
Squared.
Squared.
3 times 3x squared is what?
9x cubed.
Squared.
Yeah.
And then 3 times 3x is?
9x.
I'm running out of room. And then 3 times 5 is? 15. Sorry, I had to scrunch them up over there. And then what do we do now?
Start adding together.
Like terms. Does 6x to the third have any buddies?
Cubed.
No friends.
We got
put your squareds together. So 6x squared plus 9x squared is 15x squared. And then 10x plus 9x is what? 19x. And then keep the plus 15. Yeah, and I hate it. I make David sit on his hands.
It's God's first calculator.
Actually, I had 6 in there. All right. So that's a binomial times a trinomial. So then we get to get a little algebra 2 in us and do a trinomial times a trinomial. Yep. So you might want to start a whole nother line for this one. 3n squared plus n minus 5 times 5n squared plus 3n minus 7. Two trinomials. Okay, without being too specific, tell me, how are we going to attack this? Tell me what you think. You're going to use the distributive property 3 times. So we're going to start with 3n squared and multiply it times all 3 terms in the second trinomial. Same thing with n times all 3 terms. And then negative 5 times all 3 terms. So just tell me, y'all lovely mathematicians, after I've finished multiplying, how many terms will I have written across there? How many?
1, 2, 3, 9.
3 times 3 is 9.
Once you add
Right.
them together.
But I'm talking about after I multiply, then I'll combine. Yes. But see, like when we did a binomial times a trinomial, how many terms did we have when we first wrote them out? We had 6, didn't we? Yeah. 3 times 2 is 6. So here we go. 3n squared first
Times 5n squared.
times 5n squared is what?
15n to the 4th.
Good. And then 3n squared times 3n is?
9n to the 3rd.
Mm-hmm. And then 3n squared times negative 7 is?
Negative 21n squared.
Yep. Yep.
Okay, so you do n.
Then you go to n. So n times 5n squared is what? No? It's 1 times 5. Okay, good. And then you do n times 3n is? Yep. And then you do n times negative 7.
Negative 7.
Okay. And now what we do?
5 times 5.
Negative 5.
Negative 5.
Times all 3 terms.
Negative 25 n.
Squared.
And then negative 15 n.
Okay.
And then 35 negative.
Positive or negative?
35.
Yeah, positive. Because a negative times a negative is a positive. We're done multiplying.
So we'll add them
9
together
terms, right?
sometimes.
9 terms.
Put you squared together.
Just my squares?
These cube together. So
Togethers.
9n.
I love it.
So 9
Wait.
plus 5 is
Let's start.
14n.
We got to do it. Let's go in order.
Oh, we got a 4 one up there.
We got to end to the 4. So,
15n to the 4th
all right, I'm going to underline them as I go.
plus
Then the cube. Got all my cubes?
14. Yep, 14n to the cube.
And then squares. How many squares do I have?
3.
3. So negative 21n squared. Let me underline them
They're all
blue.
minuses, so
Yeah, let me put them all in blue so we can see them different. All right, what's negative 21n squared
21.
plus 3n squared is negative 18n squared, right?
Negative 21 plus 3 is 18.
That's what I just said. And
18
then
plus 25.
negative 18.
Negative.
Uh-huh.
Uh-huh.
Wait, 18 and 25 is not.
Negative 18 minus 25. Negative 43.
That's right. Negative 43n squared. And then my n's, I have a negative 7n minus 15n is what?
20.
Negative 22n. And then I just have my plus 35.
That is muy complicated.
It's just muy long. Not difficult. We did multiplying and adding. That's all we did. It's just long. So y'all gonna have 20 of these on your homework. Just kidding. Like 2. That's it. But that's how you do a trinomial times a trinomial. You just take every term and multiply it times every term. That's it. Okay? So let's multiply 3 things together.
Let's do 3 trinomials.
Well, it's actually, we're going to make it nicer than that. I'll just do 3 binomials. I'm not that evil today. Not today. Okay. So I have 3 binomials I want to multiply them together. Somebody tell me somehow I could do this.
Let's start with foil method.
Foil 2 of them, right?
Why can't you foil 3 of them?
Just foil 2 of them. Because foil only works with 2 binomials. And then you can multiply the other one. That's what I would do. Multiply 2 of them together. It doesn't matter which 2 you do. And then multiply that answer times the other one. Okay? Y'all just want to do the first 2 to start with?
W times 4 will be
W times 4W is what?
4W2.
Squared. W times -1 is?
-1W.
-6 times 4W is?
What?
-24W. And -6 times a -1 is a?
Positive 6.
And then these are like terms. So 4W squared, -25W plus 6. One's a square, one's not. No, because when you add them, you don't combine like you combine like terms, but you don't change the exponent. So now I can multiply this trinomial times this binomial. So that's what I get when I multiply the first 2 binomials together. And then I've got to multiply that times -3W plus 5. Now this is a binomial times a trinomial. So if you want to, on your paper, you can reverse the order, right? Or you can do it without reversing the order, which is what I'm going to do. You're still going to take the -3W and multiply it times all 3 terms, and then you're going to come back and take the 5.
You don't do the 3 times the 2. You're going to do 4W.
Times
Squared.
-3W. And then these 2 times each other, and then these times each other.
Okay.
And then you do these 2, and then these 2, and then these 2. Okay? So I'm going to start with -3W times 4W squared, and what's that? Third. And then -3W times -25W is what?
75.
Positive 75. W times W is W squared. And -3W times 6 is what?
18.
-18W. And then you go back and do the same thing with 5. So 5 times 4W squared is?
20W squared.
5 times -25W, -125W. And 5 times 6 is? 30. And what's the last thing you have to do?
Add them together.
Like terms.
So you got that, what, -12W.
The third.
And then you got
The W squares.
75
Mm-hmm.
W squared.
Oh, forgot my 5, sorry. 95W squared. -18W minus 125W.
142, 143.
-143W. And then plus 30. And there's your answer. So anytime you have 3 binomials to multiply together, you do 2 of them to start with, and then come back and do your third.
I feel like I'm going to get confused on when to use what for.
Yes, you use FOIL when you have 2 binomials. Anything else, you have to use distributive property.
FOIL is distributed.
It is. But you can only call it FOIL if you have 4 terms. A binomial
So
times
you
a binomial.
always use distributed.
I always use distributed.
You're either adding or you're either multiplying.
If you're adding, you're just combining like terms. You don't change exponents. If you're
So we don't
multiplying,
have
you can.
Are we going to have a subtraction with the 3 binomials?
Not on this homework. It's always just
So it
2.
ain't going to be too long. You going to show us some division?
No, because this is only goes through multiplying. Now we're going to talk about some special products now. We will do division, but that will be in another chapter. Those are called rational expressions.
Why can't we further break them down?
Because they're not like terms.
But 95W squared. So you can do
It's
95.
not like terms with anything else because there are no other W squares.
But 95 squared is 9,025.
You're not factoring. You're just multiplying. Don't overcomplicate. Trust me. All right, let's talk about special products for a second. Example J. X plus 4 times X minus 4. If anybody can tell me what kind of special product this is, I'll buy you a Coke tomorrow. Thank you, Josue. What kind of Coke do you like?
X plus 4 with the 2 on the end.
What kind of Coke? You like Dr. Pepper? What do you like?
Yeah.
Okay. Difference of squares. So if you're multiplying 2 numbers that are difference of squares, there's a shortcut for it. Y'all remember the shortcut?
Just put a 2 on the end.
Not even close. You can't just stick a 2 on the end.
You got to put it on the power. On the outside of the parentheses.
Of what?
Parentheses, X minus 4, parentheses, no.
No, you can't do that. No, can't do it. All right, okay, you could FOIL this, right? We could FOIL it. Let's FOIL it. Let's do it the regular way. X times X is X squared, right? X times negative 4 is negative 4X. 4 times X is positive 4X. And 4 times negative 4 is negative 4. And then I combine like terms and what happens?
X cancels out.
They cancel out and I'm left with X squared minus 16. So if you don't remember the shortcut, guess what? FOIL it, you get your answer. But here is the shortcut, and it only works for difference of squares. They have different signs, though. That's what makes them cancel out right there, is they have opposite signs. Now, the shortcut to difference of squares is first you have to recognize, hey, it's a difference of squares. And it's only a difference of squares if they have 2 binomials. Okay? A binomial and a binomial. Same first term. Same last term, and opposite signs in the middle. If you have same first term, same last term, and opposite signs in the middle, it's a difference of squares. Okay? If it's a difference of squares, you can use this shortcut. Take your first term, square it. Stick a minus because it's called a difference of squares, and difference means subtract. Take your last term and square it, and then work it out. What's X squared? Yeah. Minus what's 4 squared? Same answer, right? So if I forget the shortcut and I do it this way, is it wrong? No, it's not. So if you're not sure about the shortcut, FOIL always works. But if you recognize you have a difference of squares, you can use this shortcut. Only for difference of squares. So parentheses, difference of squares. That's a terrible square. There you go. It only works for difference of squares. So I'm going to give you another difference of squares, and let's use the shortcut. 2x minus 5 times 2x plus 5. So is this a difference of squares?
4x squared.
I'm not saying give me the answer. Is this a difference of squares?
Yes.
Yes. How do you know?
The same equation, different value.
It's not an equation. There's no equal sign.
Same problem, different value.
Same what?
Binomial.
Same first term, same last term, opposite signs, right? We gotta be Pacific.
Pacific.
Yeah, we gotta be Pacific here. I hate when people say that.
I'm Atlantic.
Yeah, me too. I'm Indian. Okay, so take your first term, square it, minus in the middle always. That's why it's called difference of squares. Parentheses, last term. First term squared, last term squared, minus in the middle. What is
4x minus
no, not 4x
4x skew is 2 power.
squared? Yes.
And then minus 25.
And that's it. And if I forgot my shortcut, what do I do? Foil it. All right, let's talk about something else. Not there yet. JKL y plus 3 squared. This is not the same as a difference of square. This is just a binomial square. What does it mean to square something mathematically? What does that whole concept mean?
That thing times that thing times itself.
Something times itself, right? Anything times itself is a square. So y plus 3 squared means y plus 3 times what?
Y plus 3.
Yeah. Y plus 3 times y plus 3 is that's what that means. Y plus 3 squared means y plus 3 times y plus 3. I'm going to change the color.
So does that not just mean y plus second power?
No, you cannot. There's no shortcut. That is like the most frustrating mistake that students make in algebra. Okay? I need a poster and blow it up the size of this room. Y plus 3 squared does not equal y squared plus 9. That is wrong, that is wrong, 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 wrong, wrong.
You're wrong.
Killed my marker. Slam dunk. Okay? Never, ever, ever square a binomial and just square the terms. It does not work. Okay? It's wrong. I'm going to show you why it's wrong. How do we multiply two binomials? We've already talked about this today. Distributor 4, right? What's y times y? Y squared. What's y times 3? What's 3 times y? What's 3 times 3? What's 3y plus 3y? Y squared plus 6y plus 9. Okay? A binomial squared, you have to multiply it times itself. No shortcuts for that. Only use shortcuts for difference of squares. All right? Binomial squared, multiply it times itself, FOIL it, distribute it, whatever you want to call it. Let's do another. So I feel better because I got my anxiety up showing you how to do it wrong. I know, killed my marker completely. 3y minus 5 squared. What does that mean? That means I multiply it times itself.
9y squared.
And I FOIL it. 9y squared
15y.
minus 15y. And negative 5 times negative 5 is positive 25. Like terms. Yeah. Plus 25. That's right. Are we good?
Yep, one more time.
Hold on.
I am done. That is the end of notes for today on adding, subtracting, and multiplying polynomials. Thank you for tuning in.